All right, let's go over voltage drop. Let's say this is our situation. We want 120 volt, 20 amp circuit, 87 feet away, and somebody told us we don't want to exceed more than 3% voltage drop. Let's first figure out what 3% of 120 volts is. So we have 120 volts. We're going to multiply that by 0.03 for our 3%, and that's 3.6 volts. That's 3%. So I made a note of that our 3% is at 3.6 volts. Now, let's get into the actual equation here. So we're going to be on the left-hand side for single phase. So this is going to tell us our actual voltage drop if we go off of the wire size. So 2 times K times I times L. This is all of our variables here. Over our circular mills, you find your circular mills on the back side of the card. So let's just figure this for number 12 for a 20 amp circuit. Let's see where we end up. So I did this with number 12, 2 times 12.9 times 20 times our 87 feet over just for a 12 gauge wire. So our 12 gauge wire is at 6530. We end up with 6.87 volts. So way over our 3.6 volts. That's not going to work. But since we know that we don't want to go over our 3.6 volts, let's use this other equation and find our wire size. So we're using this other equation, 2 times 12.9 times 20 times 87 feet over our voltage drop. And that comes out to 12,470. And that is our circular mills. That's the wire size we're looking for. So we flip our card over. We need something at least that size. So we go down here, and that's going to be a number 8. You can also use this for 3-phase circuits. You just use the square root of 3, so 1.732 instead of 2. So square root of 3 times K times I times L over Cm to find your voltage drop. Or instead of the Cm, you would use the actual voltage drop. Again, this VD is the actual volts. It's not a percentage or anything like that. This is the actual volts. So that's how you would use this card to do a voltage drop calculation. I also have one based on table 310.16. It's got aluminum on one side, copper on the other, so you've got all your ampacities for your wire sizes. I have one for conduit bending with your degrees, your multipliers, and your amount of shrink. Here's a little example down here on how you do an offset. Backside shows you 2 different ways on how to do a 3-point saddle, the traditional way and then the push-through method. I have one for table 250.66 for your grounding electroconductor and table 250.122 for your equipment ground. I've got a cool one with the Ohms wheel power wheel on one side. The other side is just a little cheat sheet for fractions, decimals, and millimeters. And then here's a little one for like your phasing. So, hey, what's circuit 17? Well, that's going to be C phase, and it's either going to be blue or yellow based on your voltage. Yes, I realize that these are not codes. They're industry standards. And I also have one for flexible cords and cables based on table 400.5A1. So here's that table and then all the letter designations. All of these are available on my Etsy page.